Thelma and Louise have had enough. So they start in their convertible from rest, and they accelerate forward at 2.5 meters per second squared towards the edge of a cliff that is 50 meters away. If the cliff is 60 meters high, how fast are they going? Well, how fast are they going when they reach the edge? And how much time are they in the air? And how far from the base of the cliff do they land? And I just made this water like this at Rio Grande or something. Should see the movie. It's a good movie. All right. So let's zoom in a little bit and I want to do given. So given, well, we've got, let's do this first part here. I'll resketch the problem. Delta x equals 50 meters. And here's the car. V naught equals 0. And here's their velocity right here. We'll call this velocity, we'll call this V naught x, that after they leave, but for the first part of the problem. And then what is delta y? Negative 60 meters, right? Because it falls down. Now I use negative 60 because I consider gravity to be negative 9.8. Okay. If you want to make it, if down positive, you can do that and get the right answer. So we want to find A, the velocity at the edge, and B, the time in air, and C is, I'll call it delta x sub B for base, from the base of the cliff. And, oh, I don't need to refer to that. It's going to go be from here to here. And notice it's okay to name stuff with little subscripts if you want to distinguish. Like here's a delta x over here, and here's the delta x from the base of the cliff. So you can make it up however you want to do it. Now let's solve. Ah, blessed those who sneeze. So let's do part A. Well, we know what delta x is. We know what the initial velocity is. We want the final velocity. We don't know time, and we're not trying to find the time to go from here to here. So I'm going to use the fourth kinematic equation, because that's the one that doesn't have time in it. Oh, I forgot to put the acceleration is 2.5 meters per second squared from here to here. So the final velocity is going to be the square root of, well, this is 0. Car starts from rest. And then 2 times 2.5 meters per second squared times 50 meters. Remember, this first part, we're looking at the problem from here to here. It's not projectile motion yet. It's just a constant acceleration problem like we did in Unit 2. Well, I guess I can plug all that in. 2 times 2.5 times 50 equals, and then I want to take the square root of that, so raise it to the 0.5 power, and I get 15.8 meters per second. And that's my answer for part A. Did y'all get that? Agree with that? Good. Okay, now let's do part B. Well, part B, we want to know how much time it's in the air. Well, it's in the air while it's falling from here down to here. I don't need to know the x velocity to figure out how much, because we know that when it comes off the cliff, the initial velocity in the y direction equals 0. So I want time. I know the initial velocity in the y direction is 0. I know the acceleration in the y direction is negative 9.8. And I'm trying to find time. So the third kinematic equation has those 4 variables in it. A lot of, some people still go, well, how did you know to pick that equation? Well, because it has what I'm trying to find in it, which is time, and it has the things that I'm given in it. So I can do it. Now, the initial velocity in the y direction is 0, so this whole term goes away. And now I can solve for time by multiplying both sides by 2. So 2 times delta y divided by the acceleration, and then I got to take the square root. Mine on screen, almost off screen. Two times 60 divided by 9.8 equals 12.24. Take the square root of that, and I get 3.50. Is that what you got for time? Okay. And then part C. Well, I know the time. Now, delta x sub b from the base is equal to the initial velocity in the x direction times time. Now, here's where a mistake some students might make. They might go plus 1/2 a t squared. And then there's 2 ways of making a mistake. Putting 9.8 meters per second squared in there, which is wrong because that's not the acceleration in the x direction. Or they could put 2.5 meters per second squared like we had up here. But once the car leaves the edge of the cliff, it's not in contact with the ground anymore. It can't accelerate horizontally anymore. So the acceleration in the x direction is 0 once it leaves the cliff. It's a projectile. So this goes away. And so now I just need to plug in my values. Well, what is the velocity in the x direction? Well, that's my answer to part A. It's 15.8 meters per second. And then how far did it go? Well, I have to use my answer from part B. And you get 55.3 meters. Okay? So let's zoom out, take a look at the whole thing. I had to squeeze it into the side of the paper there. So it's kind of a 2-part problem, but you have to use the 2 parts together. So this is kind of like what a free response question would be like on the AP test, where they're going to have like a 1-dimensional constant acceleration problem and then a 2-dimensional constant acceleration projectile motion type problem mixed together. So you'll have to know how to handle that. Any questions? Okay, that is all.